going to show how to make random graph paper using Affinity Photo's procedural texture filter. The first question you probably will ask is, why would you want to make random graph paper? So people were pretty surprised when I posted some of this online and couldn't understand why I would want to make such a thing. But I'll show you some examples of how I want to use this. This is an example of a map of a fantasy town I made using randomly oriented graph paper. In this case, the graph paper is changing slightly over time to form sort of an S-like curve in both the X direction and the Y direction. In other cases, I have the graph paper changing randomly, and I can also control the amount of change from one section of graph to the next. This is the sort of thing I was thinking of when I designed this graph paper. To get started, I'm going to use a new 8.5 by 11 document in portrait mode. Make sure it's in RGB mode and create that. I'm going to select black and fill this with black. That creates a new pixel layer, and then I can add a procedural texture to that. I'll start by adding an equation, assign it to all three channels, and I'll add a single custom input A. Set that up to 1, and I'll start with a coordinate system. Start with a variable v equals vec2 of rx comma ry, relative x and relative y coordinates times a divided by w. Okay, and so that's what it looks like so far. The origin is in the center. I can move that around because it's relative x and y, and it gradually changes across the red channel for the x direction, and it changes the green channel for the y direction. To create the lines, I'm going to start by using an oscillator, OSC, of v.x. Okay, and so that creates a vertical sort of line here. And if I bring up my A value now, which I'll label scale, you can see it has sort of stripes on it, which is sort of what I want. And I want to have just thin black stripes and then the rest of it white. So in order to do that, I'll start by choosing a step function around this. And I'll put an edge on it, and step and edge. And I will put down a range. I'll make E a custom input variable, and this will be the line thickness. And it goes from 0 to 1. And so as I bring this down all the way to 0, it's white. And then as I bring it up a little, I just have a little narrow line on there. Every time it gets below a certain threshold value, about 0.1, then it makes it black. Above that, it's white. So that's what the step function does. The next thing I'm going to do is to make a copy of this and multiply it. And I'm going to change v.x to v.y, like that. So now I have my grid. I can set it up here in the corner. And if I change this to 8.5, so I set this to 8.5, and I notice I have 4 1/4 of these. So it really did only half as many. And that's because the oscillator function only changes every time you go up 2 units. It does a full cycle. I have to multiply this by 2. Okay, now let's see how it came out. 8.5, and this way should be 11. And 11, so that worked perfectly. I'd like to have these sort of smoothed off so it isn't such a harsh line right there. And so I'm going to change this to smoothstep. And instead of, I have an E there, but I'm going to add another custom input, and I'll take E plus E1. So I'll call the other one E1, and I'll do the same thing here, E plus E1. And that's my custom input, and so I'll make that another 0 to 1 slider, call it E1. And then I'll change this one to smooth step also, so I'll add a smooth to the front of that, make this E plus E1 also, comma, and then add a 0 to 1 slider for E1, And now I can add just a little bit of smoothness to the edges there. So this controls the line thickness, this controls the smoothness. Now I have a basic graph paper. I'd like to be able to divide this up, so I'm going to have some divisions on here. I'm going to add another input, I'll call it D. This will be the number of divisions per inch. And I'll set this up to 4 to check it out. And then I'm going to multiply this by D. And so I position that in the corner. That looks about right. Actually, I want to have 5 divisions per inch because that's what I most like drawing with. Okay, doesn't come out to an even number on that side, but it's now in 5 divisions per inch. So I like that graph paper. That's what I want to draw with. Now that I've got my grid, I want to be able to rotate certain chunks of this by a certain angle. I need to have rotatable coordinates. So I'm going to change this to a 0. Instead of V, I'll make this one V0, and then I'll set up a rotatable coordinate system based on my V0 coordinate system. If you're wondering how to do a rotatable coordinate system, I'll put a link in the video description to another video I made that describes this in more detail. To create the rotatable coordinate system, I'm going to use v0.x times cosine of theta minus v0.y times sine of theta. And then for the y coordinate, for the rotatable coordinates, I'll have v0.x times sine of theta. And this time it's plus v0.y times cosine of theta. And I need to put in an angle input, theta. I'll call it th for theta, and this will be the angle. I should be able to, if I hold the shift key down and roll this to any angle, I can get whatever angle I want. So I could do 3 degrees, whatever you want. Otherwise, if you don't hold the shift key down, it'll go in 45-degree steps. Okay, so there's the rotatable coordinate system. Now I want to only rotate it during a like a random number. So in order to see this, I'm going to create this, make this a variable. I'll call it just T1. And instead of having this be an angle as an input, I'm going to create a variable theta, and that is equal to noisei. I'm going to use the noisei function, which is a random, generates random pixels. But if I base it on this V0 coordinate system, it'll have like, the pixels will be really big, I guess. That's one way to think about it. And then I'm going to divide that by B, and B is going to be a custom input. So I'll put about 40 of these in there. And so this will be how many little rectangles of my grid will show up in each cell. So now I'm going to go ahead and look at T1 again. It looks like it's changing, but only slightly. And the reason it's only changing a little is that this noise function only goes from 0 to 1. So I'm going to multiply this by 90. There. Now it's rotating by 90. I could really only do 45 if I wanted to, but I'll just do 90, give it a good effect. Now I may want to be able to scale this to, so sometimes I have a big change and sometimes I have a little change. And so I'm going to put in a factor, I'll call it I. This will be the subgrid size, and then this will be the randomness amount. And so I can I'll multiply my theta value by I, and then I'll be able to adjust the randomness amount. So I can have no randomness, little randomness, a lot of randomness. If I change this to about 20, then I have a lot of these elements. Now it might be nice to have a different color than just black and white. So I'm going to go ahead and add an adjustment. I'm going to do a gradient map. Just choose the default. I'm going to get rid of this green color. And then I can make this one white. And then this one, I can make a different color. And I will make this light blue. Depending on how you print this out on a piece of paper, you may want to make this a little bit lighter. Okay, the final form of the equation is variable v0 equals vec2 rx comma ry times a times d times 2 divided by w, which is width of the document in pixels. And then the next variable is theta, th, which is the random noisei function, v0 over b times 90 times I, which is a fader. And then I have a rotatable coordinate system, which is v equals vec2 of v0 dot x times cosine of theta minus v0 dot y times sine of theta, comma, v0 dot x times the sine of theta plus v0 dot y times cosine of theta. And then I have my final texture, which is smoothstep E, comma, E plus E1 OSC oscillator of V dot X, and then times smoothstep of E, comma, E plus E1 oscillator of V dot Y. And then I just have T1 to show the texture. I made a couple other variations of this, and the trick to it is varying this variable right here. There's my basic random graph paper. I can move it around to different positions. I can change the amount of randomness, and I can change the size of each of the cells for the random cells for this. That's the basic process. I made a couple other variations on this, and I'll put those in the description for this video. There's one using Perlin Noise, and then the other one uses the map I showed earlier that has sort of a gradually changing grid that sort of changed as a smooth wave like this. All right, that's the random graph paper. Let me know if you have any comments or questions, and thanks for watching.